All right. Good morning, everyone, and welcome to another iteration of the long coffee break. My name's Billy Donovan. I'm on the air distribution sales team here in Littleton, Colorado. And today I want to talk about a different approach to critical room controls. If you've ever had a critical space that took 3 days to balance and still wouldn't hold pressure, well, this presentation will probably resonate. So let's get started. I'll begin this presentation by asking, why are critical rooms so difficult? Some, or maybe many of you, might disagree with the implication of that question, but it's a rational assumption, so bear with me. When we design a critical room today, the system isn't really put together until startup. The sequence gets interpreted, devices get tuned in the field, and the system behavior is finalized during commissioning. On top of that, the components comprising the system are sourced from multiple vendors, so your air valves and controllers and sensors, and multiple contractors, mechanical controls, tab, all play a role in the installation and commissioning of that critical space. So when things go wrong during commissioning, the finger pointing begins. Under this method, there must be some level of cooperation between all these stakeholders in order to prevent project delays and, as well as, maintain the designed outcomes. So at the very least, the traditional method for designing, installing, commissioning critical rooms is complex. And I want to believe that most people in the industry would agree with that. All right, so what does CRC do differently? Well, think of it like this. Instead of assembling the system in the field, CRC's integrated room solution is assembled at the factory. Everything is designed and programmed to work together before it even arrives at the job site. Rather than just integrating components, CRC is selling you a pre-engineered packaged room. So at this point, you're probably thinking, well, there are other valve manufacturers that offer comprehensive systems, and you're not wrong. There are some very sophisticated airflow control platforms on the market today. Phoenix is a great example of that. Their critical spaces control platform is extremely capable, but at its core, it still relies heavily on control contractors programming and field coordination. Integration happens across devices in the field. Their valves have intelligence built into them. The controls logic is distributed across the valves and BAS. It's an advanced system, but fundamentally, it's still a system built from smart components. CRC's integrated room solution, on the other hand, is different in that integration happens at the room level. They package the entire room solution and take on responsibility for how that room actually performs. Again, the entire control strategy for the room is designed, programmed, and coordinated before it hits the job site. So what am I getting? What does this all look like? Well, let's walk through it using an example of a compounding pharmacy as an example here. For something like this USP 800 compounding pharmacy illustrated on this slide, we'd approach it as 3 individual spaces. Our non-hazardous room, our anti-room, and our hazardous room. Looking at the anti-room, we see there's a supply valve, an exhaust valve, display monitoring the conditions of that space. And this room will most likely also have a handful of sensors like room pressure and temperature and humidity, occupancy sensors, and so on. So now that we know the room layout, here's what we can expect from the factory. Every CRC job will come with a component list, room layout, and a wiring schematic. It may not be readily apparent, but it really doesn't get much easier than this. Using this documentation, an installer knows every component that's part of the room system. They'll know the wiring poles for the entire room, and even where each wire is landed on the controller. This alone eliminates a lot of the coordination between contractors and vendors during the installation phase. Next, every CRC job comes with an IO summary. This, in combination with the written sequence of operation, removes a lot of the guesswork for TAB during commissioning. CRC's integrated room offering is as close to a plug-and-play solution as you can get. Now, it doesn't eliminate commissioning, but it can dramatically reduce the discovery, the programming, and the fine-tuning that traditionally happens during startup. And here's just a quick example of CRC's factory backnet points list if BAS integration is involved too. So what are some of the benefits for, say, engineers? Well, instead of writing a complex sequence and hoping that the controls contractor interprets it correctly, CRC delivers a system already designed around your sequences. This means less interpretation by everyone involved and less variation between jobs. CRC's IR solution is non-proprietary. This isn't a black box with dedicated access and software licenses. The owner isn't going to be handcuffed to any particular controls contractor or even to CRC. While a room system is pre-engineered at CRC's factory, the system remains totally open to configuration. Offsets, set points, pressures, and so on can all be adjusted at any time through the touchscreen display in the room. This open architecture allows for scalability too. We can go from a simple tracking pair to a full-blown teaching lab with multiple supply valves and general exhaust valves, and I don't know, like 14 view modes if you wanted. But the user experience is all going to stay the same. How about some benefits for our contractors out there? Well, one manufacturer is responsible for how the room performs, so you know who to point the finger at if anything were to go wrong, but we also know who to go to for support. Faster installs and simplified commissioning. CRC valves can be mounted in any orientation, and there are no inlet or outlet restrictions. In addition to the factory, long sales and service teams are here to support you with these jobs as well. Typical applications for CRC's integrated room solution are critical environments where pressure relationships and airflow control matters. Labs, ORs, isolation rooms, pharmaceutical or microelectronic manufacturing are all good examples. So in closing, why should you choose CRC's integrated room solution for your next critical room project? Well, CRC's IR solution streamlines and simplifies the design, installation, commissioning, and operation of critical spaces. By simplifying critical room controls, we're not removing any of the safeguards or strategies. We're standardizing and pre-coordinating them. In many cases, that actually reduces risk because there's less variability in how the system gets implemented in the field. It's open architecture. Owners aren't handcuffed to expensive proprietary platforms, and contractors aren't handcuffed or forced to deal with, say, a difficult vendor. And all the performance benefits of CRC's closed loop Venturi technology, which I didn't even have time to discuss today. But if you are interested in learning more about it, we did do a coffee break, and it's posted to Long's YouTube account. It's back on August 4th, 2022, but Dan Evans goes into a lot of detail on all the benefits that come along with their closed loop Venturi technology, things like um, high turn downs and passive indirect static pressure management, commissioned accuracy, and low pressure drop design. It's truly good and interesting stuff. If you have any questions regarding CRC's integrated room solution or just critical environments in general, please don't hesitate to reach out to your Long sales engineer. If anyone's going to be at the IASPE vendor show tonight in Boulder, please stop by the Long booth and say hi. We'll have some CRC demos on our table with us. And yeah, let's get on to this week's winner of the Coffee Break Prize. Your gift choices for this week are a $100 Best Buy gift card, an alcohol infusion kit, or a shark onesie. Please join us next week for a direct fired makeup air overview presented by Mark Stuckman and our own Austin Whiteley. Thank you very much, and we'll see you next week.